that we just want to find these expressions, just first of all, try to think of them mentally. So on the first one, it gives us 5 divided by 1/6. Now, before doing any of the math on it, I'm just going to think about it mentally for a minute. I have 5, and then I'm going to be dividing that 5 into sixths. So I'm taking that 5 and I'm dividing it up even to smaller pieces. So now I know, just thinking about it mentally, my number should be higher than 5 because I'm taking that 5 that I had and making them into smaller sections. So I should have more sections now. So if I actually do the math on it, I would place that over 1. When I'm dividing fractions, I slide the first one over, I flip or do the reciprocal of the second, and then I multiply. So I would have 5 times 6 is 30, 1 times 1 is 1, or simply 30 whole ones. And that makes sense to what I was talking about mentally. I knew if I had 5 of something, but then I took that 5 and I split it up into sixths, I should have a higher number than 5 pieces now. I should have more number of pieces, and I did. I had 30 pieces now. So we've been talking throughout the unit, and we keep saying that dividing by 1/6 is the same as multiplying times 6. And if I look at my math, once I've done all of that, then yeah, what I got at the end was 5 multiplied times 6, and I got 30. So dividing by 1/6 is the same as multiplying by 6. On the next one, it gives us 5 whole ones, but this time it's saying that we are multiplying. Now, is multiplying by 6 the same as dividing by 6? No, that's not the same, is it? That's different. So when we're talking about mentally on this one, I know that I have 5 and I have 1/6 of 5. So am I going to be probably thinking about a fraction here, or am I going to be thinking about a whole number here? And I think I'm going to be thinking, my answer is going to have to be a fraction because I have 1/6 of 5. So if I do the math on it, then I know I would have that. I would slide that on over. Now this doesn't change this time, does it? Because we're not dividing, we're multiplying, so it stays the same. We just simply place this one over a 1. 5 times 1 is 5. And 1 times 6 is 6. So we have 5/6. So that fits into my mental reasoning. I said that I had 5 of something, but it was split in 6. So each of those should be a fraction. So I end up with my fraction here. Now, we've also talked this unit about it does matter what order you divide in. So the next problem, it gives us 1/5 divided by the whole number 6. Now, previously we had the whole number on this side and the fraction was over there. So we knew that we were taking that whole and splitting it up more times. So we were thinking, okay, then my answer is going to be higher. But this time, we have something, it's already in fifths. All we have is a little fifth of something. Like if we had a fifth of that macaroni and cheese, you know our macaroni and cheese. If we only had a fifth of a pan, and then we had to split that pan up between 6 people, there's no way that any of the people are going to get a whole one. So we know that our number is going to be less than 1. We know that our final answer should be a fraction, because I'm taking 1/5 of something that's already small, and then I'm having to divide it up 6 more whole times. So I think it's going to be a fraction. So let me go ahead and work my problem out now. I've already done mentally in my head what I think. So I know that I would slide the first one on over. I would flip or do the reciprocal, and that's really 6/1. So if I flipped, I would have 1/6 and then I multiply. So I get 1 times 1 is 1, 5 times 6 is 30, for a total of 1/30. And that fits what I said mentally. In my head, I said that my number should be a fraction lower than 1 because it was already just 1/5 that I had, and I was dividing it up 6 more times. And then finally, the last one. It gives us 1/5 times 1/6. So if we think about this in our English terms, we know that usually almost always multiplying means of in math. So if I only have 1/5 of something that was 1/6, I know that number is going to be really little too, isn't it? Because it was only 1/5, and it was only 1/6, and if I only have 1/5 of that 1/6, I know it's going to be small. So I know it's going to be a number less than 1. And when I actually do the math, we are just multiplying, so nothing's going to flip. Both of these were already written as fractions, so we don't have to place anything over a 1. So we simply multiply straight across. 1 times 1 is 1. 5 times 6 is 30, for a total of 1/30. And that makes sense. We just said a few minutes ago that we knew it was mentally, we knew it was going to be less than 1. Now, if we start to look at the relationship between all of these numbers, because we were using 5s and 6s, 6s and 5ths, and we kept getting things that had to do with 30. So if we start to look at all of that, now we can see clearly that what we've been talking about through the unit is true. Dividing by 1/6 is the same as multiplying by 6. And then if we think of dividing by a 6, dividing by a whole number, is dividing by a whole number the same as multiplying times its flip, its reciprocal? Yeah, so we're starting to see the pattern between all of these. Now, one thing we do have to keep in mind, make sure you always watch. What is this first number? What's going on over here with the first number? Because it does matter what order you divide in. So if you start with your whole number, and you're dividing by fractions, we know that that final answer is going to be larger than the 5 we started with. If we start with the fraction and we're dividing that fraction up again, then we know that our number is going to be smaller than what we started with. So that's the pattern of what we've been seeing throughout this unit, and I hope now that you're starting to put that all together. It does matter what order you divide in. Dividing by a fraction, you're going to end up, it's the reciprocal, so you're actually multiplying times the denominator. If the fraction is first and you're dividing by a whole number, then your answer is going to end up less than 1. Okay? Now, we're going to skip page 91 because that would have been a group activity that I would have had to have been there with you for. So instead, we're going to turn to page 92. It gave us some extra problems that are optional just in case we didn't get to do the group activity, which works out perfect. So we still have the same type of problems. It's just now we're going to be doing them all together instead of as a group. Okay, on page 92, it says, solve each problem and show or explain your reasoning. Now, I talked about yesterday, sometimes you can show or explain your reasoning just by doing your expression, but if it helps you to draw it out, then draw it out. So we're going to do this one both ways today, right now. It says, if 11 grains of rice weigh 1/3 gram. Now think about that. That's 11 grains. They weigh 1/3 all together. So then it says, how much does each grain of rice weigh? So the first thing I have to think about is my total weight. My total weight is 1/3 of a gram. Okay, and that 1/3 of a gram is being divided by 11 whole grains of sand, or grains of rice, not sand. Okay, so I have that 1/3 gram, that's all the weight I have, that's being divided by those 11 grains of rice. So I know, since I'm dividing and my fraction part comes first, it's a small 1/3, and then I'm having to divide that between 11 grains of rice. So I know mentally that my number should be a number less than 1. So then I'll work out the math like I know to do. I put this over 1. I slide my 1/3 on over. I flip the second, or do the reciprocal, and then I multiply. 1 times 1 is 1. 3 times 11 is 33. So each grain of rice is going to be 1/33. Now, if it helps you, there's 2 different ways that you could graph this out. One way is if I had my bin of rice, and I knew that this bin was originally in thirds. But then I had to think of this bin of rice, and I said, okay, but then each third actually contains 11 grains. So I could split one of my thirds into 11 pieces, okay? So I know that each of these would be 1/11, correct? Okay, so then if I look at it like all of these were filled in, if all of these were filled in, I'm not going to do all of them on these because it's 11 in each one, but if all of these were filled in, then this would be 11 of them, this would be 11 of them, this would be 11 of them, for a total of 33. And if only one of the grains of rice was shaded, how much of those 33 would it be? It would be 1/33. So the same thing that we got by doing the expression, but if it helps you to draw it out, then definitely go ahead and draw out your diagram. I hope you guys are starting and stopping these videos as you need to work in your workbook and think about your answers. You don't have to just let it run. Stop it how you need to. That's why I'm doing video. Okay, on the next one, Mai's road is 9/10 of a mile long. She ran 3/4 of her road. How far did she run? Okay. Now, one thing that you could do is you could say, okay, she ran 3/4 of her road. She ran 3/4 of her road, and her road was 9/10. So she ran 3/4 of 9/10 of a mile. And we know that of in math is multiply. So if I had 3/4 of, which we say is multiply in math, 9/10. Now I'm multiplying fractions, and again I say multiplying because we're not flipping anything because we didn't start off dividing fractions. So we would just multiply straight across. We would have 3 times 9 is 27. 4 times 10 is 40. So Mai ran 27/40 of that road. Now, again, if you need to look at it as a diagram, just think about it this way. Okay, she had, her road was 9/10. Now, her road has been divided up into fourths. Fourths, see, because we were dividing into fourths. So we know that each one of these, we know that she ran 3 of these, right? Okay, so if she ran 3 of those, and we know that the first thing we would need to know is how much is each fourth? How much is each fourth? So if I had my 9/10, if my 9/10 was being divided up into fourths, my whole 9/10 was divided by fourths. Now this one we would slide across, we would flip, and we would multiply. So on this one, we have 36 over 10. Now, does that make sense? Doesn't make sense to me. So, what did we do here? We had a fraction and then we divided it up by a more fraction, but we got a high, because this is going to end up being 3 something. That's not possible, is it? So that's why I always think about your possibility of your answer. Is there any, because this would be 3 and we would have some left over, wouldn't we? the 36 divided by 10 is 3 whole ones, and then we would have 6/10 left over. Well, that doesn't make any sense, does it? This can't be 3 6/10 of a mile, and this 3 6/10 if the whole thing is only 9/10. So think about your mental math. So instead of dividing by 1/4, what if we did, if we had 1/4 of 9/10? Let's see if that makes sense. 1/4 of means multiply. So we would have 1/4 times 9/10. So we would have not 90, we would have 9/40. Okay, that makes sense, doesn't it? Because if my whole thing, the whole distance that she ran is 9/10 of a mile, so it makes sense now that each fourth of that mile would be 9/40 of a mile. Okay, so that makes sense, doesn't it? Mentally, that makes sense. I had a fourth of 9/10. Well, it was like 9/10 divided into 4 or multiplied by fourths. I know I'm going to have a fraction, so that makes sense. Each one is a small fraction of the complete 9/10. So now I can just add those up. I had 9/40, and then I have 9 more, so that would give me 18/40. And then 9 more would give me 27/40, because remember, it said she only ran 3/4. So she ran 27/40. So no matter if we do it by expression or diagram, we still get the same answer. And that answer makes sense because if her road wasn't a mile, wasn't even 1 whole mile to start with. So if she didn't run but 3/4 of it, it makes sense that she ran a fraction of a way, not a whole number mile. Okay, now on this last one, it's really going to make, this one, we're dealing with a mixed number. But the way they give us this mixed number, it's easy to do mental math on it if we think about the relationship between English and Mathlish. It says if each tennis ball weighs 2 1/16 ounces, how much do 9 tennis balls weigh? So I have 2 1/16, and I have that 9 times. Each tennis ball is 2 1/16, and I have 9 of them. So I am multiplying. Now, we know that we can turn our mixed number into an improper fraction by multiplying diagonally and then adding the top. So we would have 16 times 2. And if you're not sure, just go to the side and do the math. 2 times 6 is 12. Carry our 1. 2 times 1 is 2, plus the 1 that we carried is 32. Okay, so we would have 32 when we multiply this way, plus 1 more, so we would have 33/16. And we know that we always put this over a 1, and then we would multiply straight across. And again, we would just go to the side and do the math. 33 times 9. 9 times 3 is 27. 9 times 3 is 27, plus the 2 that we carried. So 297 over 16 times 1 is 16. Now, we could divide top to bottom, 297 divided by 16, or let's look at it this way. Now remember when we were talking about distributive property, just how something's distributed or laid out, spread out? So this one, remember in distributive property, the whole number part, we have this 9. And this 9 is being multiplied times 2. And, because we've talked about the plus sign, plus means and in math, and it's being multiplied times the 1/16. So we have our 9 that's being multiplied times 2, and 9 being multiplied times 1/16. And then we can see what comes out of there and add them together. So if I multiplied 9 times 2, I would get 18. If I multiply 9 times 1/16, I would have 9 over 1 times 1/16. Do that just a second. So we would still bring that down. 9 times 1 is 9. 1 times 16 is 16. So I have 9/16 coming out of there. I would add them together and I would have 18 and 9/16. So it doesn't matter if I had taken this very large improper fraction and divided 297 by 16, I would have ended up with 18 whole ones and then 9 left over, and we were working in 16ths, which still would have given me 18 and 9/16. So whether you want to work it out this way and turn your improper into a mixed number, or if you want to look at it as distributive property, how it's laid out. 9, again, was being multiplied times 2, and, keyword, and 9 was being multiplied times 1/16. So then you would see what comes out of each set of parentheses, add them together, and you would get 18 and 9/16. So that's going to wrap it up for today. And let me see if I can find Bailey again. Maybe I can find her better this time. Let's see if I can find that girl. Bay! There's Bay. There's Bailey Grace. Say hey. Say Mommy misses everybody. Bye, guys.